All right, all right, all right. So, talk to me. How's the homework coming? All right, nothing wrong with that. Catching up? Okay. Which one? Okay, gotcha. The factoring. Yeah, yeah. So, I'm thinking like realistically, we should all be caught up by Monday with all the homework. So we have time. All the homework that's necessary for the second exam has already been posted. So you guys can go take a look. Everything else is, I mean, we still have stuff to learn today and tomorrow, but like, it's all been posted what you need already. Sorry about that, the projector. No, 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 for the holiday. So I'm thinking about like at the end of this class, maybe we'll do like a little poll. If you guys want to do it on Monday or Tuesday. Yeah. I think you guys will be ready by Monday, for it. But just know that like, Monday we learn a new material though. Yeah, that's the only thing. Make sure this. So yeah, what about you? Like how's homework? All caught up? Can't remember her name. Yeah. These next couple of homeworks, like one of them is only 5 questions. I think that's nice homework. It's not too bad. Yeah. Hey, what's up, man? Hey, go ahead. That's it? So just factor it? All right. So first things first, what should I look for first? Risk common factor, right? And what is that gonna be here? 2, right? So then I'm left with what? X squared, 15, right? Yeah. And then two numbers that multiply to 15, but add up to 8. That's like what, 5 and 3? So x plus 5, x plus 3. That's it. Yeah. Let's see. You're welcome. Hmm? Add up to 15. Like, oh, my fault. This is a 5. My fault. My fault. I gotta work on that. I'm saying for the top part, adds up to 16 and multiplies to 30. Yeah, like, that's true, but I pulled out the greatest common factor first. So now it has to add up to 8 and multiply to 15. 8, okay. Yeah, yeah. All right, go ahead. Wait, say it again? Is like this, n times n minus 1? Equals. Like this? All right. Oh, 28. Like that? All right. So basically what I want to do, I want to distribute this. So I'm gonna have what? N squared minus n is equal to negative 128. And then right after I do that, I'm gonna add and minus 24. Oh, 4. So this would be like 24n, right? But same process. I'm gonna add 128 to both sides, right? Because I want to get rid of the 128 on the right-hand side. So now what do I have? I have n squared minus 24n plus 128 is equal to 0, right? So now I want two numbers that when I multiply it will give me 128, but when I add them together will give me 24, right? So easiest way to do this, right? Use that tree, right? So we have 128. Break this down into like, let's say 64 and 2, right? 2 is prime, so I'm done. Break that up, let's say 2 and 32. And then break this up, let's say 2 and what's that, 16? And then you kind of get the idea, right? 4 and 4, and then kind of ran out of space here. 2, 2, 2, 2. Right? So I have 1, 2, 3, 4, 5, 6, 7 twos, right? So I have to figure out some number that's gonna involve those twos right there. So maybe I might combine, let's say, 4 of them together, right? So so let's say like this one, like 2, 2, 2, 2, right? So 2 times 2, 4. This would be 8, this would be 16. All right. So 16 times 2 times 2 is 4. And then another 2, call that 8. So 16 times 8 is 128, right? 16 plus 8, that happens to be 24, so that's it. Well, I was just guessing. I was just cutting it in half. Like I didn't know that, to be honest. So what's gonna happen here, right? This is gonna become, we're gonna have n here, n here. My 128 is positive, which means that either both of these numbers are positive or both of them are negative. In this case, they're gonna be both be negative because the b term is negative. And then we said 16 times 8. And then after that, just set them both equal to 0. So n minus 16 equals 0, and n minus 8 is equal to 0, and then just solve for n. So I'm going to add 16 over here. What I do to one side, do to the other. So I have n is equal to 16, and I have add 8 over here. What I do to one side, do to the other. So I have n is equal to 8. These two are my answers. Right? So yeah, when the number gets crazy, just remember that tree, to break it down.
You can also just do AC.
You could. So AC method would be 1 times 128, which will give you 128, and then your B term is negative 24. So two numbers that multiply to 128 and add up to negative 24.
That's what I think that I think it was.
Yeah.
That's what August is.
Yeah.
It's the sum, something like that.
And right, yeah, it's the same thing. Yeah. I've seen some people do it like that. Like they have this kind of like an X that they'll do here. And then this side would be like the sum, and then this side would be like the multiplication. And then I feel like up here would be the number that you're looking for. Something like that. Yeah. Yeah. I mean, but when you guys learn like the third method, you guys might fall in love with that and never go back to this. Which I wouldn't be mad about, because the third method is pretty awesome. Mhm. Anybody else, any other questions from the homework? You guys could like totally ask and I'll do your question and you just type it in and click enter. Real simple.
Yeah, problem 6, 7, 8, 9, 10.
I mean, that's a lot.
Yeah.
I mean, I like it, I don't know, maybe they're on their way. I like it when we do different questions each time, you know?
Oh, different like sections.
Yeah.
Yeah, we got y squared plus 9y plus 20.
Same thing like this. Y squared, what?
Plus 9y plus 20.
That's it? So to factor it? So you have y here, you have y here. Two numbers that multiply to give you 20. What are they? And they have to add up to 9. I see that the C term is positive. Exactly. And that's it. 32x. So first thing you want to do is put everything on the same side, right? So I'm going to subtract a 32x from over here. Where I do the one side to the other. So now what do I have? I have 2x cubed minus 32x is equal to 0, right? So what's the first thing I should do here? Right? And what is it? 2 what? 2x, right? So remember, it's like I'm dividing by 2x, like I'm dividing by 2x, right? What's left over? X squared. Exactly. Equals 0, right? And then now this is the difference of two perfect squares, right? So break it down for me. What is that going to be? X what? And what? Exactly, right? But now here's a trick. Here's a trick right here, right? You got to set each one of these equal to 0 individually, right? So I'm gonna have the 2x is equal to 0, right? Divide by 2, divide by 2, so x is equal to 0. I'm gonna have the x minus 4 is equal to 0. Add 4, add 4. So I have x is equal to 4, and I'm gonna have the x plus 4 is equal to 0. Subtract 4, subtract 4. So I'm gonna have the x is equal to negative 4. All three of these are your answers. That's that. Any other questions on the homework? Don't be shy. It's okay. Probably at the end of class, we'll decide when we're gonna do the test. All of the necessary homework for exam 2 has been posted, so you guys can take a look. Yeah. I was thinking about if I could get through today, I was thinking about doing that tomorrow. But I would give it to you tonight though. All right, so if there's no more questions, then let's just jump into the lesson. Yeah, it's not too bad today though.
Wow, it's great. Near after.
Yeah. All right, but before we even like jump into the lesson, let's do something fun. Let's do a little blast from the past. All right. How do I do this again? I have 3/5 over 9/10. Mhm. It's a fraction divided by a fraction. What do I do? We did this before. On like the second day. Like your second homework. How do I do this? It's good, man. Yo, help me out. How I do this again? How I do this again? Help me out. Help me out. How I do this? Nah. Division. Say it again? Getting closer, not keep, change, flip. That's what I'm looking for, right? So I keep the top, change the division to multiplication, flip the denominator. Remember this? And then just multiply straight across, right? So this becomes 3 times 10 over 5 times 9, right? Which is 30 over 45. And you know you got to reduce it, right? So 15 goes into 30 2 times, 15 goes into 45 3 times, so we have like 2 over 3.
Oh, wait. Are the problems there early, so?
Hmm?
Yes. The one that we did that.
Which one was that? This one? 128? No? This one?
Yeah.
Right. Mhm. I mean, you could pick the smaller numbers and then just keep doing the smaller numbers until you can't do anything else anymore. That's fine too. It's okay. How about this? What do we do here? Eventually, but before that, what do we do? All right, we have to simplify the numerator and simplify the denominator first before we can do keep, change, flip.
Oh, like
right?
you square it before you solve the question.
Right. So let's deal with the numerator first, right? I have 1 minus 1 over 3, right? Now, you know 1 is the same thing as like 1 over 1 minus 1 over 3, right? Now, how do I subtract the fractions? What do I need to do? Said it earlier. Right? What's the common denominator here? 3, right? So all I got to do is multiply this by 3, but what I do to the bottom, I do to the top. All right? So what does this become? This becomes 3 minus 1 over 3, which is 2 over 3. Right?
Calculate can't do it.
Yeah, I could. So, yeah. For the bottom now, though, right? How you doing? I got 4 squared plus 4 times 5, right? Literally just do the math on that, right? What's 4 squared? Oh, 16, right? And what's 4 times 5?
Or 20.
20, right? And then when you just add those together, what's that become? That's like what, 36? And because it's a whole number, I'm gonna just put it over 1. Now we can do keep, change, flip, right? So we have the 2 over 3. I'm gonna change that to multiplication and flip this to become 1 over 36.
Now it's a proper
Right?
fraction.
Right. Right. And then now we just multiply straight across, right? My fault. I'm gonna reduce this real quick before I do that because that's a lot of work. So 2 goes into 2 ones, 2 goes into 36 18 times. So this becomes what? 1 times 1, 1 over 3 times 18, which is what? 108? For real?
3 times 18?
Yeah.
54.
54, all right.
And 3 times 36.
Got you. Nah, I just reduced it.
You did? Oh,
Yeah.
wait, you're supposed
Yeah.
to reduce it as much as possible.
Yeah. I didn't want to reduce it at the end though, because 3 times 36 scared me.
Can you still reduce it?
No, we good. It's 1 over 54. Nothing else, you know. So I get what you're saying. Like 54 is not prime. It can get broken down even more. But the thing is that whatever I'm reducing it by has to reduce the top and the bottom. Yeah, so since one is like, you know, yeah, then it's done. How about this? Might look crazy, but we could do this, all right? What do I need first? LCD, right? So what's the LCD here? Close.
2x.
Nope, close. Little bit bigger than that. Huh? Bigger than that. 8, what? 8x. Very good. Hmm? So it's 8x is my LCD, right? So basically, I want to get every single denominator here to be 8x. So for 2x, what do I have to multiply that by to make it into 8x? By 4, right? But remember, what I do to the bottom, what I do to the top. For 4, what do I have to multiply that by to get 8x? 2x, right? Multiply this by 2x. Whoops, 2x. Well, remember what I do to the bottom, or I do to the top. How about the 8? What do I have to multiply 8 by to get 8x? By x, right? What I do to the bottom, or I do to the top. Now, once I have the same denominator across the board, this is only true for an equation, right? This is an equation, and we know that because there's an equal sign. Once I have the same denominator right across the board, all I have to do is focus on the numerator. So what does this become? 1 times 4 plus 1 times 2x is equal to 1 times x, right? Hey, let's do the math on that. This becomes what? 4 plus 2x is equal to x. And then just solve for x. Nothing crazy here, right? I'm gonna subtract 2x from over here. What I do to one side, I do to the other. So now I have 4 is equal to negative x. I'm gonna divide by the -1 to get rid of the negative. What I do to one side, do to the other. So I have x is equal to -1. And that's it. Right?
This is leading up to the lesson.
Yeah. Now, technically speaking, this is a example of something that I have to check to see if the answer is right. All right. The reason for this is because remember earlier in the lesson we were learning that it's illegal for us to divide by 0. Sometimes we might find an answer and it's legitimately an answer, but when you plug it in, it makes the denominator 0. You know, so that it's actually an extraneous solution, so we can't even use it. Right? So we have to check our answers in this particular section. Right? All the other sections were cool. So let's look at how to check our answers real quick. It's kind of like a new lesson, right? So to check our answers. So we have 1 over 2x. My fault. I'm gonna be doing a little bit of scrolling. 1 over 4. So plus 1 over 4 equals 1 over 8. Right? So what I want to do is I want to plug in the -1 to verify that that actually works as an answer, right? So this is going to become 1 over 2 times -1 plus 1 over 4. Allegedly, that's equal to 1 over 8. Let's see if it works, right? So this becomes what? -1 over 2 plus 1 over 4 allegedly is equal to 1 over 8. Now, in order for me to add or subtract, I have to have the same denominator, right? LCD over here is going to be 8, right? Same thing. So I'm going to multiply this 2 by 4, but what I do to the bottom, I do to the top. I'm going to multiply this 4 by 2, what I do to the bottom, I do to the top, right? So what does this become? This becomes -1, open parentheses 4, plus 1 times 2, all divided by 8, and allegedly, that's equal to 1 over 8. I don't know if it's true or not, but we're going to see, right? So this becomes what? -4 plus 2 over 8. I don't know. Is that 1 over 8? Let's see. -4 plus 2. What is that? That's -2 over 8. I'm not sure. Let's reduce that. What does this become? -1 over 4, right? But does that equal 1 over 8? It doesn't. Right? So that answer that we found, which is legitimately the answer, doesn't work. It's an extraneous solution. Right? So in this particular section, we have to check our answers. All right?
Checking is more than actually solving the problem.
It is, yeah. So the real answer is no solution. That's what you would write. Hmm? Sure, sure. So what we're doing today is we're kind of combining all three of these ideas. And we're gonna see how to do these. Hmm? 4 divided by negative what? Where? Oh, that is -4. Whoops. You're right. Good catch, good catch, good catch. Yeah, let's go back and check that real quick. My fault. Let's see, this is -4 right here, then that means that this becomes 1 over -8, right? But then like still we gotta multiply this by 2. We'll do the one side due to the other, and we'll reduce the bottom due to the top, right? Good catch, good catch, good catch. Well, we know -1 is not a solution. Anyway, right? I have -1 over 8 plus 2 over 8. That might be equal to 1 over 8. Let's see. Right? This becomes -1 plus 2 over 8. Maybe that's 1 over 8. Let's see. 1 over 8 is equal to 1 over 8. So boom. That is a solution. Good job. Good catch. My mistake. Oops. So yeah, that is a solution.
So we have to check it
Yeah,
on the test?
yeah. This section, yeah. Because you have to verify that the answer that you get actually works.
What's
Yeah.
the name of this?
This is rational equation. Equation. We're gonna get some more of that though today. So here's what we're really getting into at first, right? We're gonna be simplifying a complex rational expression by writing it as division. So complex fractions are fractions in which the numerator or denominator contains a fraction. So we previously simplified complex fractions like this, 3 over 4 divided by 5 over 8, right? We just did that. Or like x over 2 divided by x times y over 6, right? In this section, we will simplify complex rational expressions, which are rational expressions with rational expressions in the numerator or the denominator, right? Let's take a look. Just for our understanding. Complex rational expression. So a complex rational expression is a rational expression in which the numerator and or the denominator contains a rational expression. Just give me a little definition. But let's take a look. Promise you this is really, really easy. It's not that bad at all. So I want to simplify this complex rational expression by writing it as division, right? So here's how I do it. I'm going to write the numerator, 6 over x minus 4, divided by the denominator, 3 over x squared minus 16, right? And you already know what the next step is, right? Keep, change, flip. So I'm going to keep the 6 over x minus 4, change that division to multiplication. In this case, I'm going to use the dot multiplication because we have a lot of x's in this example, right? I'm going to flip the other one. So this is going to become x squared minus 16 over 3. After this, you know exactly what to do, right? Factor it, right? Let's factor this. So this becomes what? 2 times 3 over x minus 4 times x minus 4, x plus 4, all over 3, right? And then you already know what's going to come right after that. I'm going to cross out the like terms, right? So x minus 4, 3 and 3, right? So what am I left with as my answer? 2 times x plus 4. Very good. That's it. Questions on this?
Yeah, no, test, the next test.
It's this test coming up. Does it make sense? Which 3? Which 3? The first one
No, we started there.
with the pink, this one?
Yeah.
Or you mean this top one up here? So,
All that part.
so for this one, I just factored the 6 into 2 times 3. Right? Yeah. And then the x minus 4, x plus 4, that's just the difference of 2 perfect squares up top there. Right?
You can't cross out those.
No, there's nothing, yeah. It'd have to be on the bottom or diagonal from it for me to be able to cross it out. And that's it. I don't know, I feel like this topic not so bad.
I just don't remember the bad stuff.
I got you.
This is still fresh.
Mm-hmm.
So it's crazy, they said it's a problem.
Is it? I
Yeah,
don't know.
it's not good.
You guys try that. Yeah.
Forget it, it's got side effects.
Yeah. Colors your teeth, right?
I'm sure if the gum does.
Yeah.
Yeah, probably. But nothing good with bad side effects.
True, true. So yeah, we're just simplifying these. It's not so bad. When you guys are on your test and you're doing like the rational sum, and you're doing like the rational expression stuff, right? A tip that I have for you guys is think about how you would do this if this was just plain numbers. All right? Because it's the same process as the regular whole numbers, right? And then we're just putting polynomials in it. But it's that same process again and again. Gotcha. you guys go home, I don't know if anybody here is into News 12, but Lehman College was on News 12 today. Yay for them.
Was the thing or that?
Good thing, yeah. They
Like, so that's
they
that.
got they got placed on some list that of like the best colleges in America kind of thing, like in the top 100. And they're not better than BCC, right?
Exactly.
Good for them.
I heard a lot of people like this.
BCC is,
Like
is
some
the
of the sounds
bomb.
of 4 year.
BCC is the bomb, you know. You know that BCC was the first community college in CUNY.
I don't, they told me this used to be NYU.
Mhm. That's why if you look outside, like Google Memorial that they have right here, like on the building itself, it says NYU. Even like some of the buildings, like um, I feel like Meister but definitely McCracken over here, right? Like those were NYU chancellors.
I know my building, they said there used to be a dorm,
Which one is that? Oh yeah, yeah, yeah.
like a
That
shower
that
there.
yeah, that was a dorm, and next to it also a low hall. That was a dorm also. I think I want to say CPH was a dorm. I think Colston was a dorm also. Yeah. All right, let's take a look. I mean, like, there's no answer to this though. It's just a reduction, you know. So,
Do a fraction.
well, it's possible. Let's see. Try black, right? So I have 2/x² - 1 divided by 3/x+1, right? So I want to keep change flip, right? So I'm going to keep the 2/x² - 1. I'm going to change that division to multiplication. Again, I want to use a dot multiplication in this. And I'm going to flip the other fraction over here. So it's from x+1/3, right? After this, factor, right? Just factor it. So this becomes what? 2 over x+1. Very good. Times x+1/3. After that, just cross out the like terms, right? This and this looks alike. Done, right? Then multiply straight across. So what does this become? 2/3 times x-1. And that's it. Nothing else to do there. All right. Questions on that? Yeah, yeah. Always keep change flip. Hmm? That's what we're doing all day today. Yeah. We're gonna vote at the end, either Monday or Tuesday. Think Tuesday? All right. I mean, most people want Tuesday. I think it's only me and like somebody else that wants like Monday. Yeah.
Unless you're doing it open book at home.
Open book at home. That's not gonna prepare. That's not gonna prepare you for the final. All right. So look, fraction bars, right, act as grouping symbols. I don't know if we remember this from our earlier lesson. So to follow the order of operations, we simplify the numerator and denominator as much as possible before we can do division, right? So we had spoke about this earlier. I think this is like the first week of class. So this is like a little bit of a blast from the past right here. So same thing. I'm simplifying the complex rational expression by writing as division, right? But I have to simplify the numerator first, then simplify the denominator, and then when I have a fraction divided by a fraction, I can do keep, change, flip, and blah, 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 all that. Yeah. So look, here's how we're gonna do this. So I have one. Hold on, let me get a pen first. I always make that mistake. All right, so this is 1/3 plus 1/6, right? Now, in order for me to add two fractions, I have to have the same denominator, right? So what's the LCD here? Not 18, 6, right? So to make the 3 into a 6, I have to multiply this by a 2. What I do to the bottom, I'll do to the top. To make the 6 into a 6, I have to multiply this by a 1. What I do to the bottom, I do to the top. That's the reason why I did that. I could have used the 18, to be honest with you, but I'd have to reduce it more at the end. Yeah. But if you see 18 on the test and you want to use it, go right ahead, because it'll work. Yeah, it will work. So this is gonna become what? 2? Let me not say that. Huh?
You can't do the bottom.
No, individually you do them. Then at the end we'll put them together. So this becomes 1 times 2 plus 1 times 1 all over 6, right? Which we know is just 2 plus 1 over 6, which is 3/6. We're good? All right. So that's just the numerator. Let's look at the denominator, right? For the I'm sorry? I could. It's probably smarter to do that too. I could do that. All right, let's do that. All right, well, we're gonna hide that over there. So I want to do the denominator now. I have 1/2 minus 1/3. Help me out. What's LCD?
Still 6. Oh, no.
Oh yeah, this one is 6. Very good. All right. So now to make the 2 into a 6, I have to multiply this by 3. But what I do to the bottom, I do to the top. To make the 3 into a 6, I have to multiply this by 2. But what I do to the bottom, I do to the top. All right. So what does this equal? This equals 1 times 3 minus 1 times 2 all over 6, right? Which becomes what? 3 minus 2 over 6, which is what? I forgot those lines. 1/6, right? And then 1/6 can't be reduced, so 1/6, right? Now I have a fraction divided by a fraction, so I can keep, change, flip. Let's do that, right? So now I have 1/2.
Why would you keep it? So that it goes first.
I should have done that, right? It's all good. It's all good. It'll still work. So I'm gonna keep the 1/2, right? Divided by the 1/6, right? Then I'm gonna keep, change, flip. So I'm gonna do 1/2 times 6/1, right? Multiply straight across. What do I get? I get 6/2, right? Which we know was gonna reduce to 3/1 or just 3. And that's my answer. Sure. I feel like this is a lot, so let me just like do one of these. I could probably hit it one time up. Yeah, I think that's it. So yeah, moral of the story, simplify the numerator by itself, simplify the denominator by itself. All right, and then when you have a fraction over fraction, keep, change, flip, reduce. Mhm. Over here. Mhm. It just happened to be that way. But just know that when I'm looking at it, I'm looking at the numerator by itself, then I'm looking at the denominator by itself. Right? This was just a really nice, easy question. But it doesn't have to be that they have the same LCD. Mhm. The 3/6 would have been even easier, all right? Because let me see. Oops. Exactly. So like the 3/6 would have looked like this: 3/6 divided by 1/6, and then 3/6 times 1/6. I mean 6/1. I'm sorry, I forgot how to flip. All right, and then you could just do that, and then just get 3. Yeah, but your procedure was right. Like I should have reduced it. Huh? Yeah. All right. I'm gonna zoom it up real quick where I could get the. So I feel like it's like a really small font. Well, all right, you guys try. Say it again. This was hard? Really?
Market using
All right, let's take a look. So. All right, I have 1/2. Bless you, plus 2/3, right? I'm gonna add these two fractions together, right? But I need the same denominator to do that. 6, right? So to make the 2 into a 6, I gotta multiply this by 3, but what I do to the bottom, I do to the top. To make the 3 into a 6, I have to multiply this by a 2, but what I do to the bottom, I do to the top. Right? So this becomes 1 times 3 plus 2 times 2 all over 6, which is what? 3 plus 4 over 6, which I think is 7 over 6. Something like that, right? And then I have, on the bottom now I'm looking, I have 5 over 6. That was a good 5. Okay, that was a good 5. Plus 1 over 12. Right? LCD is 12. Very good, right? So to make this 6 into a 12, I have to multiply this by 2. What I do to the bottom, I do to the top. To make the 12 into a 12, I have to multiply this by 1. What I do to the bottom, I do to the top. Right? Keep going with this. This is going to become what? 5 times 2. You're right. 10 plus 1, yeah. Plus 1 times 1 over 12, which becomes 10 plus 1 over 12, which is 11 over 12, right? And my fault, I forgot to do the lines through all of them. It's my mistake. All right, but now I have a fraction over fraction. I have 7 over 6 divided by 11 over 12, right? So we're gonna do keep, change, flip, right? Well, before we do that, let's write it as division. 7 over 6, right? Divided by 11 over 12. Keep, change, flip. So this is 7 over 6 times 12 over 11. I'm gonna reduce right now because my math is not as strong as yours. So 6 goes into 6 1 and 6 goes into 12 2 times, right? Multiply, yeah, you could do that. Multiply straight across. 7 times 2, what's that? 14. And 1 times 11. Somebody help me out. What's that? 11. Thank you. My 1 times table was not so strong, you know. All right. And then boom. That's my answer. Sure. Let's get one more. I think that's it.
I got 8.
84 over 11? Got you. So 84 over 66, yeah. And then you can reduce it by 6.
Okay.
Yeah. Be honest, I didn't know what 7 times 12 was. That's why I did that. That being said, this was all stuff that we did like our second day in class. So yeah. So let's get to what we really want to get to, which is this, all right? How to simplify a complex rational expression using division, right? So simplify the complex rational expression by writing it as division. So I have 1, whoops. I always do that. I always forget my pen. Right? So I have 1 over x plus 1 over y, right? I want to find the LCD here. What's the LCD here? Don't overthink it. No. XY, right? That's it, right? So to change the X into an XY, I have to multiply this by Y. But what I do to the bottom, I gotta do to the top. To change the Y into an XY, I have to multiply this by X. But what I do to the bottom, I have to do to the top. Right? So what does this become? This becomes 1 times Y plus 1 times X over XY, which is equal to what? Y plus X over XY. Did I lose anybody?
Yeah.
Where I lost you? Where did I lose you?
Oh, wait.
Let's multiply them together. Let's multiply them together. LCD. It's the same thing as before though, right? Oh. The 1/2 and the 2/3, right? LCD was 6, so we just multiply this by 3. Yeah, but it's the same thing. Promise you it's the same thing. Yeah. Basically, you just multiply the two denominators together. And what you do to the bottom, you do to the top. Same process, nothing changes. All right, let's try it again. Let's try it again. How about this, right? So in the denominator, right, I have X over Y minus Y over X. So what's the LCD? Don't overthink it. XY, right? So how do I change the Y into an XY? By X, right? But what I do to the bottom, I gotta do to the top. How do I change the X into an XY? Multiply by Y, right? But what I do to the bottom, I gotta do to the top. Right? Same thing, nothing changes. It'll be there. So this will become what? X squared. No, I shouldn't do that. This will become X times X minus Y times Y all over XY, right? Which will become what? X squared minus Y squared over XY. It might look crazy. No, we're not done yet. It might look crazy, but this is a fraction over a fraction. Keep, change, flip, right? Or first, let's rewrite it. So I have Y plus X over XY divided by X squared minus Y squared over XY. Now keep, change, flip, right? I have X plus Y over XY times, I'm going to use a dot multiplication because there's a lot of X's going on over here. XY over X squared minus Y squared, right? Real simple after that, factor it, right? What does this become? X plus Y over XY times XY over X plus Y, X minus Y, right? Difference of two perfect squares. After you get that, cross out the like terms, boom, 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 boom. So what am I left with? A 1 over X minus Y. And that's it. Nah, they gotta be variables. We did that already on the first test. Remember that question? No, the number version of it. Yeah. No, but we need it from at 30 though, that's why. I think I can hit it one time. Let me see. Yeah, we good. So remember, when in doubt, for the whole same denominator thing, just multiply the two denominators together and call it a day. Right? You can always reduce it at the end, no problem. Mhm. Right. When you factor it out, yeah. And you cross out the like terms, bam, bam, and that's it. I can zoom it in now. Yep. All right, this is easier. You guys try. Everybody finish? Now let's take a look. All right, so I have one, hold on. I have 1 over x plus 1 over y, right? What's the LCD there? XY, right? So to change the x into a XY, gotta multiply this by y, right? What I do to the bottom, do to the top. I have a y, to change that into an XY, I have to multiply that by an x. What I do to the bottom, I do to the top. All right? So what does this become? This becomes 1 times y plus 1 times x.
Oh, so
All
it's
over
y
x,
plus
y?
X.
Mhm.
It's just y plus one of one.
Exactly, right? So I have what? X plus y over xy, right? Let's look at the denominator. I have 1 over x minus 1 over y, right? What's my LCD there? X and y, right? So to change the x to it, right? Multiply by y. Multiply this by x, right? And it's a bottom to the top. So what do I have? I have 1 times y minus 1 times x all over xy. You already know that's going to become what? Y minus x over xy. That's simple. Keep, change, flip, right? Or rewrite it, whatever. Right? X plus y over xy divided by y minus x over xy. Now keep, change, flip, no mistake, x plus y over xy, put this in parentheses, times, I'm gonna flip this, xy over y minus x. These will cancel. So what am I left with? Over y minus x, very good. That's it. Questions on this? Yeah, the same thing. Yeah, for addition, yeah, and multiplication, yeah.
Cause I have y plus x over.
Y minus x, that's fine, yeah. Yeah, go ahead.
Little by little.
Yeah. It freezes sometimes when I do that, so. Right, they all over, right?
Over there by the exit.
Yo, they always by the exit.
Walking and it was in the bushes right next to me. Before that was over here by you know, the gym.
Yeah.
In the cage with like
Mhm.
I was like, oh, so there.
Sometimes they come in front of Meister and all
Wow.
that. The skunks. Yeah, we got skunks on campus,
I'm not
yeah.
gonna lie.
We got raccoons too.
Listen, fear in my heart. I see it.
Yeah.
I was like, oh God, shit.
I
They
wish,
just breaking no reason if they get scared.
if they scared, yeah.
They get scared.
But they're kind of bold though, like they legit Bronx skunks, you know?
Try and do the hezzy on them.
Right?
It was sprayed and they like.
Yeah.
But they was sprayed a little bit. But
Nah, but these skunks is gangster though, like, yeah. These not like them upstate skunks, like these Bronx skunks, you know, they walk right next to your foot, like, what's up? All right, so I just want to give y'all a little bit of notes real quick. So to simplify a complex rational expression by writing as division, step 1, simplify the numerator and the denominator. Step 2, rewrite the complex rational expression as a division problem. Step 3, divide the expressions. That's it, right? Let's take a look at another question. Hmm? Yeah.
You have the same problem.
Yeah, y'all do.
Everyone in the whole.
Yeah,
They might be scrambled there.
yeah.
Oh,
Yeah.
changes for everyone.
Huh?
It's not the same.
Like-
exact
Like the
problem.
numbers are different, but it's the same thing.
You gotta
Yeah,
find the same problem.
yeah.
So like, the problem is different, the same steps to solve.
Same steps, yeah. But the numbers are different. Mhm. All right, let's take a look at this one, right?
So like shuffle some for everybody.
Yeah, kind of. I mean, not really.
We have
Like your number one is like his number one. It's just that like maybe he has like 5 and you have 6, or something like that. Yeah, yeah. So some random thing. All right, so simplify the complex rational expression by writing it as division. Right, same thing. Right. The difference here, I got a whole number. Yikes! What do I do when I have a whole number?
One
Mhm.
over.
1 over, right? Mm-hmm. Wait for Sean. Oh, I got you. All right. So I'm gonna put that over 1, right? Minus the 4n over the n plus 5. Now I notice these are fractions, right? They're being subtracted. So for me to subtract them, I have to have the same what? Denominator, right? So what's the LCD here? Don't overthink it. N plus 5, right? So I'm going to multiply this by n plus 5. What I do to the bottom, I do to the top. I'm going to multiply this one by 1. And what I do to the bottom, I do to the top. All right? That's simple. So this becomes n times n plus 5 minus 4n times 1 all over n plus 5. All right? Keep it going. With the multiplication, you already know. Distribute. All right? So this is going to become what? N squared plus 5n minus 4n all divided by n plus 5. Let's keep going with that. That's going to become n squared plus what? What is that? Plus n, very good. All over n plus 5. Need a little more. Yeah. All right, let's go back at the bottom now. Yeah, it is. Oh, I didn't write it, my fault. Which 5? Right, I distributed, yeah. All right, let's look at the denominator real quick. I have 1 over n plus 5 plus 1 over n minus 5. What's the LCD? No. N plus 5. No. Right. Right. Both of them together. Right. Yeah. Oh no, just put them together. That's it. So to change the n plus 5 into a n plus 5 times n minus 5, I'm going to multiply this by n minus 5. But what I do to the bottom, I gotta do to the top. All right. To change the n minus 5 into a n minus 5 times n plus 5, I have to multiply this by n plus 5. But what I do to the bottom, I gotta do to the top. All right. So let's see what happens. This becomes 1 times n minus 5 plus 1 times n plus 5 all over, open parentheses, n minus 5 times n plus 5. All right? Let's distribute, multiply these out, blah, blah, blah. So we know that this becomes what? N minus 5 plus n plus 5 all over n minus 5, n plus 5, right? Let's combine like terms. And hold up. See, I don't forgot this division thing throughout the whole problem. Nobody said nothing. All right. So now I want to combine like terms in the denominator, right? N plus n, what is that? 2n. And then negative 5 plus 5 is, what's that? 0, right? Good. And then I have my n minus 5, n plus 5. All right? Mm-hmm. No, that's too much. That's too much work. So now let's rewrite this. What do I have? I have n squared plus n over n plus 5, right? Divided by 2n over n minus 5, n plus 5. You guys already know, right? Keep, change, flip. So I'm going to keep this as n squared plus n over n plus 5 times, right? Flip the other side, so I have n minus 5, n plus 5, all divided by 2n. Let me factor the numerator on the other one, so this is going to become n times n plus 1 over n plus 5 times n minus 5 times n plus 5 all over 2n. So now I want to cross out my like terms, right? I have the n plus 5, the n plus 5. I have the n and the n right here. So what am I looking at as my final answer? I'm going to do it on the bottom. Hold on 1 second. There we go. Yes. So n plus 1 times n minus 5 over 2. And that's it. That's my answer. Huh? Okay, sure. Yeah. Let me just like zoom it out because it'll be a lot of like back and forth. Where'd you have it? Oh, nah, we have to factor it because it's gonna cancel out with the n on the denominator.
So you gotta move all the way to that one. One. Plus
So for the numerator you're talking about or the denominator?
so.
Yeah. Right. That's from the denominator. So that's the bottom part up here. The 1 over n plus 5 plus 1 over n minus 5. Yeah. Yeah. So we gotta kind of solve those individually first. And then we can do the keep, change, flip and all of that good stuff. Yeah. The 2?
Yeah.
Oh, so n plus n is 2n, and then negative 5 plus 5 is 0. So that's how I got the 2n right here. You see right before it, n plus 2n? Yeah. That's how I got 2n. I'm going n plus n, which is 2n. So whenever we have a whole number, put it over one, LCD, same old thing, boom, boom, boom. All right?
Listen.
Yeah.
Five plus n plus five equals two n and not n squared. But n squared would have been n times.
Yeah. You talking about the denominator or numerator? Which one?
Well, this is the denominator.
Okay. Well, I didn't distribute that one out for the denominator. It was like I left it n minus five, n plus five. But I'm doing that on purpose because at the end of the day, I want to factor and see if any like terms are gonna cancel out.
But why did you do the top?
Cause. So for the top one,
For the denominator, but why? Two and on the denominator.
I had to. So you see how the numerator has n times n plus five? I had to distribute that and then combine the like terms and then factor it out again. Right? Because there are two different terms being added or subtracted. I don't know what would happen to them. So you have to distribute that first and then factor it.
We're not doing this.
It's possible. I haven't made it yet, so I don't know, but it's possible. I mean, like I have your review, I just didn't make the test yet.
Did it right now.
Hmm? The test, no, I didn't make that yet.
No, I mean the review.
Yeah, I have that. I want to give it out today if I get to finish today. I have like one more topic after this. For real? This is so easy.
Not this.
Is
The one that we did before that?
Got the first. Got the first of the play. It's like it's the.
So wait, try with this.
What is it?
Simplify it. Y'all homework for this section is mad long. So y'all know. I prepare for all night of homework.
That's the next homework is 6 questions.
Nah, I think this is like 5.
5.
Yeah. Yeah. I think we did more questions in class than y'all have for homework.
The winners are gonna be up to 5 more. 5 questions.
I mean, if y'all interested, tutoring is open tomorrow.
That's
Anybody
right.
wanna come? Yeah, I'll be there tomorrow. Tomorrow is Wednesday the 3rd. No tutoring on Thursday though, so y'all know. Yeah, but tutoring is open on Friday, Saturday. Not in person, online.
Friday.
No, right, online. No, no class Thursday. I mean, we actually on Thursday, we all got to report to Manhattan. Got to go watch that fireworks show. Yeah. So I got some of the technicians to write a rational expression, like using the fireworks, so it's gonna appear, and y'all just have to solve it. I don't know, but I always feel, I don't want to jinx it, but I always feel like 4th of July is like the hottest day for like the summer, you know?
It's supposed to be out.
Yeah,
What are you doing?
let me see. I'm kind of just judging by today. Today don't feel too bad, you know?
Like,
Oh yeah, yeah. But it don't feel bad. Like it's not like 100 or anything, you know? So it says 4th of July is 84. I mean, I take it. Humidity. It's a good question.
Or maybe
64.
probably feel like
Yeah. Yeah.
Okay.
And then on Friday and Saturday it's gonna rain. Yeah.
probably the first year, not so hot.
Yeah. I hope that that means that the rest of the summer won't be too hot. We might actually get snow this year for Christmas. That'd be nice. Yeah, I can't believe we went like a year and change without snow. Like,
Didn't this snow a little bit though? But it
that
wasn't during.
for me, that don't count. Like one of them times it snowed at like 3, 4 in the morning when I was asleep, so I don't count that. Like, yeah, I woke up and like, if the news didn't tell me, I wouldn't know. No lie, during that time, I was kind of worried. I thought I'm gonna be talking to like future generations of people and be like, "Yo, back in my day, we used to have this white thing called snow." Um,
Not happening.
right?
London,
Yeah.
everything.
I remember when I was a student at BCC, right? Like it snowed bad. I mean, bad, right? But Bloomberg was mayor, and Bloomberg was like, snow or no snow, go to school. Yeah, so we all had to find our way to school. Yeah. But you know, how can I say this now? Like Bloomberg would never close the schools, right? But this particular day was so bad that we had a half day. So by noon, he was like, "Yeah, all right, y'all can go home."
I think I was in like, I don't know, I used to type, like, it was S about
Yeah.
like delayed opening. I wanted to go.
Right. Yo, that's what happened to me. In the winter, remember I was saying that one time that I went online with the class? Yeah, because delayed opening, you know? I'm not gonna lie, I remember growing up and when they have those delayed openings and school cancelings and stuff, right? I remember turning on the TV and they have like a little ticker with all the schools going across, telling you whether they delayed or I never see my school. Never, ever. Even when I was
praying,
yeah,
like,
even when I was here at Bronx, never, ever. Never see it. No. Like how I know is I go to the website and they always flash it in red across the website, what's gonna happen. Yeah.
Yeah, do you see the debate yet?
No, I didn't watch it.
The debate is
Didn't
great.
watch it.
So
So,
rather than just talking about ball,
yeah.
so you can't even hit 50 yards. Why
Like,
is over there stuttering? Like, what is he talking
so
about?
you know what happened debate night? Like, I was here, I was watching like the first, let's say 10, 20 minutes, right? In my opinion, at that point, I was like, I'm done because I already know who won.
Correct.
Yeah. But then like what you call, because you know I have to do the download and all that. So I was just trying to get home. I thought I would make it, but by the time I got home, it was over. Oh,
Yeah, that was for Bernie. I thought Bernie was.
Bernie was dope. Yeah.
Nobody really messed with him. I don't know why.
I mean, I wanted him to be president, but I don't know. Hillary worked her magic and got him booted. So you know, Bernie came on campus a couple of years back and he gave a speech on campus.
How old is he? 'Cause
Good question.
I feel like you need to be at age when you're too old. Cognitive decline.
Right? Yo, what's his name? The head of the Republicans and the Senate, not the Senate, the Congress, Mitch McConnell. Yeah, he be going through stuff like that. The memes online with Mitch McConnell are crazy. Bernie is 82.
Oh, I like to say around the same age, but
Um,
it's too late.
wow. I know his birthday was 3 days before mine. He's 81. He'll be 82 this year.
I guess it is age and he's acting like why.
Yeah.
But apparently he had a lobotomy or
Who, Bernie?
device. He said he had like something breaks her.
Did he?
So,
That sucks. Dang.
he was talking nonsense.
I mean, they said a whole lot of stuff. They were saying how he was gonna be like drugged up on caffeine or something. Because they were saying how his State of the Union was so amazing. So they figured that like that kind of person was gonna come out to the debate. Um, funny stuff. All right, let's take a look, right? So I have B. Wait, hold up. Always make that mistake. Always, always. All right, so I have B minus 3B over B plus 5, right? Because B is a whole number, excuse me, I'm gonna put that over 1. What's my LCD here? B plus 5, right? So I'm gonna multiply this by B plus 5, the 1 by B plus 5, but what I do to the bottom, I do to the top, B plus 5, right? And then the B plus 5, I'm gonna multiply that by 1 to make it into a B plus 5, but what I do to the bottom, I do to the top. So now what do I have? I have B times, oh yeah, it's gonna be B squared. B plus 5 minus 3B times 1. All of that is over B plus 5. And then you know what I have to do next? I have to distribute, all right? So let's see what we have here. I'm gonna go across. So I'm gonna have B squared plus 5B minus 3B all over B plus 5. Now 5B minus 3B is what? 2B, right? Or not to be, that's the question. So we have B squared plus 2B over B plus 5, right? Let's look at the denominator. I have 2 over b plus 5 plus 1 over b minus 5. What's my LCD? Right, b plus 5 and b minus 5. So I'm going to multiply this by b minus 5, right? The first term, but what I do to the bottom, I do to the top. Minus 5. I have the b minus 5 here. I'm going to multiply this by b plus 5. What I do to the bottom, I do to the top. B plus 5. And then let's continue. This is going to become 2 times b minus 5 plus 1 times b plus 5 all over b minus 5, b plus 5. All right? Now let's do some math on this. Whoops. I have to distribute. So what do I have? I have 2b minus 10 plus b plus 5 all over b minus 5, b plus 5. Now I want to combine like terms. That's my next term, right? My next thing, combine like terms. 3b, not plus 5, minus 5, right? Negative 10 plus 5 is negative 5 over the, oh my gosh. Microsoft, why are you doing this?
8.
Oh man. Nah, it's not.
Something is 8.
I mean, it's probably a lot of writing, that's why. So 3b minus 5, sorry about that, y'all, over b minus 5 times b plus 5. And I forgot the division sign again. Nobody said nothing. All right. So now, right, let's rewrite this. I have b squared plus 2b over b plus 5 divided by 3b minus 5 over b minus 5, b plus 5. All right, let's keep change flip. So I'm going to do b squared plus 2b over b plus 5 times, flip this, b minus 5, b plus 5, all over 3b minus 5. All right, let's factor this out. B times b plus 2 over b plus 5. What's up? The numerator. Yep, the numerator. B minus 5, b plus 5. All over 3b minus 5. Now, let's cross out like terms. I have b plus 5, b plus 5. Dang, that's it. So, final answer. I'm going to have b times b plus 2 times b minus 5 all over 3b minus 5. This right here is my final answer. Yikes. Yeah. You should factor it. Just to verify that it doesn't cross out with anything else. Yeah. Whole 2 hours, you think so?
Don't give none of it.
Yeah.
Leave that as the problem. So cancel out whatever. That's the answer.
I mean, yeah, that's it. That's how you do it.
Just leave that part.
Yeah. Yeah, when I'm simplifying expressions, like there's no answer to really look for. Let's hit this up one more time. All right, that's it. My fault on the size. Yeah, it's just a lot of writing today. A lot of writing. Yeah. Two times -5, -10. Yeah, yeah. All right, so how's everybody feeling, y'all? Y'all ready for another section? Or y'all wanna tap out and do homework? You could do that. I mean, I have another section to go through, but if y'all wanna, whole different thing. Yeah. All right.
Yeah, 5 is not purpose.
5, no, 25 is.
Yeah,
Yeah.
so can you back X minus 5X? Oh,
Yeah.
you can.
Wait, 2x minus 5, yeah, the greatest common factor.
It's fine.
Yeah,
5.
it'll be x, no?
That X.
2x minus 5x.
Plus X plus 5.
Oh, no. So factor the x out, then it'll be x times 2 minus 5. No, that's it. Yeah. So -3x, that's the answer. Huh? I mean, yeah. I mean, I want to do another topic, but if y'all feel, oh my man, this is good though.
Wait, I just wanna know like.
So this is gonna be x times x minus 5. This is x plus 2x minus 2.
X times X, okay, yes,
Yeah. Flip that.
with this sign.
Yeah. And then just factor the top. The top is what? -4, -2. And then the bottom is x plus 5, x minus 5. And just cross out that terms. Yeah. So all right, if y'all wanna start on y'all homework, go ahead. Is it cool if I take this off? Anybody still copying? We good? Take it off? All
Saturday, Monday, right?
right. Well, let's vote on it. What y'all want? Y'all want Monday or y'all want Tuesday?
At home.
No, it's gotta be here.
And then we have to do.
But we're gonna review tomorrow.
And on Monday.
And on Monday? All right. We
I
can
feel like
look at it a
we
little
review
bit.
tomorrow.
Monday,
You think so?
no, Monday we will meet tomorrow, Monday.
Monday you be fresh.
I
Yeah.
won't be.
Cause Monday is a brand new lesson.
I do ripple.
Dang. I mean, it's up to everybody. What y'all want? Y'all want Tuesday or you want Monday? Tuesday. What you say? Friday? All right.
Yes.
Yeah.
Back to back.
So, yeah. So I hear,
I just wanna know, y'all pay, this. It's my thing.
I mean, I like,
You need some time for this.
I like Monday. I'm not gonna
I
lie.
like Monday.
Yeah.
100%.
But everybody here wants Tuesday?
Can y'all help out? We need a vote Tuesday?
All right. But still, get your homework done by Monday though. Like catch up on all the homework by Monday. Hmm? Like I said, all the topics have been posted already for the test. The next topic after this is rational equations, which is basically solving for x. Y'all know how to do that already. Y'all could probably do it tonight and come in tomorrow fresh. Up to y'all. Even that homework is only like 6 or 7 questions. So, all right. So Tuesday tests. I'm gonna stop the recording real quick.
All right, the court is done. So Monday.